See, okay, when you completed your heat load calculation, tonnage value and supply CFM values, these all, then we can go for our ducts. Okay, here duct means nothing but, just for simply we say that, okay, air supplying purpose, one place to another place, that purpose we are using these ducts. And here we are using for
Okay.
this, here we are using our ducts supply purpose, return purpose, at the same time exhaust purpose, and fresh air purpose. These four condition we are using ducts. And here you can see duct system, the conditioned air means nothing but cooling air. Okay, from air conditioning equipment means mission to proper air distribution point means up to discharge air terminal point, or air supply outlet in the room and
Mhm.
carry return air from the room back. Okay, we are supplying our cooling air to the up to room discharge point, up to air terminal through the room.
Room.
At the same time we are taking return also na
Room.
hot air also from return air terminals.
Returner.
That's one. Return air
Yes,
from the
yes.
room back and air conditioning equipment for the reconditioning and recirculation. Recirculation purpose. Some conditions clients only asking fresh air. They no need return air.
Mm. Return.
Okay, that kind of situation we are using 100% fresh air. That kind of situation we are
Fresh.
mentioning FAHU, na, fresh air handling units.
Mm. Yes, yes.
That one. Next, when are you calculating your duct systems or building, that condition we need to know about two things. Classification of ducts, we have two classification. One is pressure based classification, second one is velocity based classification. Okay, here pressure based classification means we have low pressure, medium and high. Same velocity also same. Low velocity system, medium velocity system, high velocity system. If you are running any duct system, first of all we need to know about, that is low velocity system, medium velocity system, high velocity system. If you need most of the condition, you can see only you are seeing low velocity system like 2000 fpm. 2000 fpm means nothing but fpm means feet per minute. Okay, our velocity
Mhm.
speed we are mentioning in meter per second na, metric
Yes,
condition.
yes.
Okay, that
Yes.
meter per second nothing but this fm. If you need to convert
Okay.
fm to meter per second, we have here value for that conversion value. See, 1 meter per second is equal 196.8 fpm.
196. Okay.
Okay, now you are getting totally 5 meter per second. Okay, below
Yes.
5 meter per second we can say as low velocity system. But most of
No
the
velocity.
designs only we can see low velocity system, like 1200 means 3 meter per second, 2 meter per second, or 1.5 meter per second, 2.5 meter per second, like this, not a more. Most of the condition already you did some project. Now in that projects also you have specification meter per second. That meter per second always you can see
Yes.
5 below.
Mm.
Rare conditions and less condition we can see 5 above. If you are using medium and high velocity system, that condition you are getting 5 above. Okay, up to 8.2 meter per second we are considered as a medium velocity system. And up to
Mm.
4000 fpm, 4000 fpm means overall uh, 20 meter per second. Up to 20 meter per second we consider high velocity
Meter
system.
second. High velocity.
Simply you will consider 9 meter per second above all we consider as a high velocity system. Why means, for example, 196.8 is there, now you will consider 200 meter per second. Like 200 fpm is called 1 meter per second. Then you will consider 20 meter per second up to 4000. Okay, mostly this high velocity system we are using for long run ducts. Do you know long run duct and short run duct? Do you have any idea about that? Long run and short
Okay.
run? Hello,
Long run
Raju.
means like.
Tell me.
Yes, long run means like single run, like without any bends or anything.
No, 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 not that one. You can did number of routings na? In that
Uh,
routing, uh,
mm.
always we have our section A to B, B to C, like that. Now we have sections. That A to B section or a duct
Mm.
only we can see 30 feet below. 30 feet below means you will consider 3 meter below. 30 feet, not a 3 meter below. Wait, 30
Okay.
feet we need to convert it into meters now. I will convert.
Yes.
1 meter is equal 3.28 feet. See, 98, wait, we have in feet na, 30 feet.
Yeah.
Okay, we are converting into meters. See, for example, 1 meter is equal 3.28 feet divided by, you can mention 3.28. You are getting 9.14 meter. Okay, always we
Yes.
are getting our section below the 9 meters. Okay, if you got
Mhm.
above the 9
Okay.
meter, what is this section? Now we have doubt. If you need that
Mm.
section, just you
Mm.
can see here we have duct routing, for example. This is our mission, and we are supplying our cooling air to these three rooms, one, two, three. Okay, in this condition, you can observe here. Here we are supplying 3000, 2000, 1000, right? This
Yes.
condition, this one you will consider A. Okay, this point you will consider A.
Okay.
For example, I am copying this, and you can specify exactly this point, and you can mention here. Okay, section means you will consider only one branch. Up to branch we consider one section. Now you can select this is A
Okay.
and a copy. This one is B, this is C, and this one you will consider as a D. Okay,
Okay.
next this one you will mention B. Okay, one section means you will consider only A to B, this one, this section. In this A to B section,
Okay.
okay, you have more than 10, 30 feet your duct length. That kind of situation we consider that one as a long run duct. Okay, 30 feet above you have duct length, we can't balance our air constantly, we can't maintain our friction constantly. Okay, here HVAC service condition, we are calculating our duct sizing. The duct size calculation purpose, we are using some methods like equal friction method and a constant velocity method.
Okay.
These two condition, what we need to maintain? We need to maintain our friction, means pressure loss constant, or otherwise we need to constant our velocity. These two we need to maintain constant. If you have 30 feet or 9 meter below you have duct size, that condition we can maintain constant. In case you have more than that one, we can't maintain. You can remember that. Okay. Okay, that purpose we are
Mm.
using in that case is long run ducts purpose, high velocity system. Okay,
Okay.
now clear na this point?
Mm.
Yes. Yes.
Now you can see that's why this high velocity system means you will consider that one. Low velocity system, medium velocity system, and a high velocity system. They are characterized by air velocities up to 2000 fpm. 2000 fpm, one to 1 meter per second is equal 196.8 fpm. You will remember that and you will convert simply. Okay, next, here we have some matter. Already you have this PDF, you will read same what I said, that matter is there. Why means if you are using low velocity system, we are getting pressure loss also low, at the same time leakages also low, and at the same time final ESP calculation. Okay, we need to calculate external static pressure now, that ESP value also you are getting low, and we are adding our safety factor ISP and safety factors, and we need to know about, sorry, fan selection process.
No.
When you know your ESP value, we can select our fan value very easily, fan capacity. In case if you need to design complete mission, that condition we need to select fan also, na?
Mm.
That fan selection purpose, definitely we need to calculate our ESP, external stat pressure. Okay, that purpose that is very useful. But you can balance low velocity system, automatically reduce your operating cost. At the same time, running cost also. Running cost will decrease automatically. Low velocity system high velocity system condition, initial cost also increasing some, at the same time running cost also increasing, both increasing. That's why most of the clients ask balancing their cost. Okay, some clients only they are asking comfort, they no need to balance cost, like that. Depends upon the client requirement, we
Okay.
need to balance our cost also here. Okay, no, you can read this one, you are
Okay.
getting that points, not a problem. Next, pressure classification. In this pressure classification condition, just you can see duct systems are also divided into three pressure classifications, matching the way supply fans are classified: low pressure, medium pressure, and high pressure. First of all, what is low pressure and what is medium pressure and what is high pressure? Low pressure means the term low pressure applies to system with fan static pressures less than the 3-inch water gauge, water column. Okay, do you know this word water gauge or water column, guys?
No.
Mm.
And remaining person,
No, no.
do you know pressure units? Pressure units. In metric condition
Mm.
also, you are mentioning pressure loss na. Okay, that
Mm.
pressure loss condition, how can we mention your units? In pascals na PA.
Mm.
Okay,
Ah,
that
yes.
pressure loss, that is metric condition, this is imperial condition. Okay, here 1 inch water column is called how much of pressure loss. Okay, how much of pascals, we need to know about that one na. If you need that information, first you can consider 248 pascals or 249 pascals you will consider. 1 inch of water column or water gauge, both are same pressure loss unit, this one also in inches condition, imperial condition. If you need, you can convert directly also. Okay, see, 1 inch WC water column to pascals. See, for example, here we have 1 inch water column, how much? 148.84 pascals. Okay, if you need to convert, for example, we have 3 inch na, 3 inch means how much of pascals? 746 pascals.
So,
In case if you have your pressure loss below 746, that condition you can prefer this one, low pressure. Okay, now clear conversion this one.
Mm.
Why means,
yeah.
when are we working that condition, definitely we need to know about imperial knowledge at the same time metric knowledge. Why means, some kind of
Okay.
situation you are getting imperial, some kind of situation you are getting metric projects. Okay, that's why we need to know about both idea. Now you can see 1 inch of water column is equal to 248.84. Okay, pascals. Generally duct velocities are less than the 1500 fpm. 1500 fpm means, already you know conversion, 1 meter per second is
Mm.
equal to 196.8 fpm. Now you can mention directly also. For example, we have 1500 fpm. 1500 fpm means you can mention
One.
196.8. Okay, 7.6 meter per second. Okay, now you will consider 7.6 meter per second low pressure. See, generally duct vessels are less than 7.6 meter per second, then we consider that is low pressure. Okay, low pressure plant. Next we have medium pressure. Medium pressure means we are using 3 to 6 inch water column. See, 3 to 6 inch. Okay, here fan system purpose. The term medium pressure applies to system with the fan static pressure between 3 to 6 inch. Okay, medium pressure or medium velocity, if you are using in your duct system, that condition we need to select our fan between 3 to 6 inch. Okay, water column or water gauge, or otherwise you will mention, already we got 745 na? Just you can mention 248.84 into 6, 1493 means 1493 pascals and 746 pascals. Okay, between these two we need to select our static pressure fan. And duct velocities are less than or equal to the 2500 fpm. Okay, if you need that one, you can convert this one also. 2500 divided by
196.8.
2 sorry 2500
196.
divided by 196.8. See, 12.7 meter per second medium velocity. Next we have high pressure calculation. In this high pressure classification condition, see, the term high pressure applies to system with fan static pressures between 6 to 10 inch, you can remember, 6 to 10 inch. 16 to 10 inch means overall you are getting 248 na, 1
Yeah.
inch means 248.84 into 10, 2488 pascals. Okay, we need to maintain, and usually the static pressure is limited to maximum of 7 inches. Maximum you can maintain 7 inch. Okay, is there, we don't have any possibility for placing 7 inch condition. Okay, that condition you can prefer more also, not a problem, but only your monthly bill will increase, running cost will increase. Okay, at the same time initial cost also high in that cases. And duct velocities are limited to 4000 fpm. Systems required ring pressure more than 7 inches. WC means nothing but water column. Some conditions we can see WG also. WG also same, water gauge. Both are pressure units only. Are normally unwarranted and could result in very high operating cost. Okay, above 7 inch if you are using your fan capacity, that one is unwarranted. They are not giving any warranty also you to. Okay, at the same time you are getting more bill in your billings. Monthly bills also increasing, current bill, simply we say like. These all you are getting in this low pressure. And here we have advantages, means good. You can read this one, you are getting that one. See, use of medium pressure classification from primary air duct work. Fan connections. Fan connection means we are getting mouthpieces na, starting condition, that one.
Mm.
And risers. Riser means,
Duct.
Stack.
yeah, ducts. Okay, that is
Right.
vertical type duct or horizontal type duct.
Well, horizontal.
Vertical.
Vertical, right?
Sorry,
Okay,
vertical. Yeah.
yeah, here risers means in plumbing and firefighting also we consider riser stack. Riser stack means nothing but vertical pipe. Okay,
Stack.
shaft
Yeah.
opening OTS areas condition we are running that. Same here, we are running our duct one floor to another floor. Now that condition we are running our ducts in shaft openings. Okay, that condition. Next, main distribution duct means main duct, not a branch ducts. Okay, main line is there now, that one you will consider.
Mm.
Next, use of low pressure calculation for secondary air duct work. Secondary air duct work means runouts or branches. Okay, here you can
Mm.
maintain medium pressure and here you can maintain normal pressure. That one also
No.
applicable. Main two terminal boxes and distribution devices means 8 terminals is there na, to that. That all. Now we got one idea about velocity classification and pressure classification, right? Then we can go for duct materials. Okay, when we are designing our duct, definitely we need to know about our duct materials, which type of duct materials we have, and where we are applying that, what are the applications for that. If you know that applications, we can do our routing better, we can select our materials also very well. Okay, that's why you need to know about this data. In this data we no need this all matter, just you can read your material names. Just you can see here, ducting is generally formed by folding sheet metal, okay, into the desired shape. For example, we are giving our routing in single line ducting, at the same time double line ducting. When you completed your duct routing, then we can go for fabrication section. After completion of design drawing, we are converting that one into shop drawing, right? That drawing we are giving to the site for fabrication, right? Each and every piece, and we are giving
Mm.
detailing for that all also. Okay, if you need to fabricate the drawing, fabricate the duct, that condition definitely we need to know how can we do fabricate and which type of material we are using for that. Okay, based on your material you are getting your cost also. For example, SS we have some high cost compared to the GA sheet, right? Like that.
Mm.
Now see, which type of shape you need depends upon that shape we can fabricate in our site. That's not a problem here in duct condition. But for example, you can go with pipe service. Pipe service, that is not possible. Okay, which type of standard availability items is there in our market, that items we need to take in that, right? You can remember that type of items we are taking in that. Next, here we have traditionally air conditioning ductwork is made of galvanized steel or galvanized sheet. Next in popularity is aluminum. Okay, mostly we are using GI sheets. After that popularity, after GI sheet we are using aluminum. Okay, and other metals also we have, that other metals used under special circumstance are copper and stainless steel. Some conditions we are using copper SS also. Metals that are used extensively depends on the application of the duct. Okay, depends upon the applications we are using that copper and SS sheets, stainless sheets. That normally we are using GA only, and some conditions we are preferring aluminum. Mostly we can see GA. Okay, but some type of situation, some type of application, for example, you can see chemical factories, we have lot of affected gases is there. That kind of situation definitely we are preferring copper or SS like that. Aluminum depends upon the application. Okay, now you can see here we have galvanized steel. Okay, means nothing but GI sheet. Okay, in this GI sheet condition you can see it is a standard and most common material used in fabrication ductwork for most common air conditioning system. Okay, the specifications for galvanized sheet are ASTM A653 and coating G90. This is galvanizing coating code. At the same time, depends upon the American standard we are using. We are taking this material ASTM, American Society of Testing and Materials. Based on this standard, you will mention this code. You are getting your properties of the GA sheet. Okay, commonly used this one. Next, we are using aluminium. In this aluminum condition, you can see it is widely used in clean room applications. Okay, clean room applications purpose we are using. These are also preferred system for moisture laden air, special exhaust systems and ornamental duct systems. Okay, this specification for aluminum sheet are ASTM B209, Alloy 1100, 3003 and 5052. These all are your material number. Where we are using, just you can see clean room application purpose. Sometimes we are preferring this. At the same time, moisture laden air condition. Okay, these two condition we are preferring that one. And the special exhaust systems and ornamental duct system. For example, ornamental we are manufacturing that condition you are generating some gases. Na? That kind of situation also we are preferring this. Okay, now this
Mm.
aluminum. Next,
Mm.
SS. SS mostly we can see fume exhaust condition. Means we have kitchen, na?
Mm.
Kitchen exhaust condition. Okay, that kitchen exhaust condition and a fume exhaust condition mostly. And a moisture laden air you can prefer aluminum or this one. Okay, mostly we are preferring moisture condition aluminum. Okay, some types of situation you can prefer this one SS. Okay, if you are using for kitchen, mostly you can prefer SS only. Next, the specification for stainless steel sheet are ASTM A16 and class 302, class 304. These all are your codes and the condition A, annealed type. This one. Do you have annealing process? Do you know that?
Mm.
Actually, annealing means.
No, no.
Do you know heat treatment? Actually, if you are doing any type of components manufacturing, okay, that manufacturing condition, we are doing some machining in CNC, right? That condition
Yes, yes.
automatically decreasing our properties of the material. Okay, that properties increasing purpose we are using heat treatment. Okay, HRC we are increasing means just we are adding our carbon composition. Okay, in that after heat treatment we are getting our output of the material. Na? In that material I need to do any machining again. That is not possible. Why? That is
Mm.
heavy strength material. Okay, that kind of situation if you need to do manufacturing again we need to do annealing. Annealing means we are decreasing our carbon composition. Okay, we are decreasing our carbon composition and we are using for machining. Okay, means we are content decreasing, carbon content decreasing in that material. That purpose we are using annealing. Okay, and for exposed ducts and finish number 2b for concealed duct. Exposed condition number 4 condition we are using. Okay, finish condition 2b we are using concealed duct means not visible. Ceiling suspended units is there. Na? That condition we have concealed type ducts. Exposed means floor to floor running ducts, OTS areas. Next, carbon steel. Carbon steel condition. It is widely used in applications involving flues, stacks, hoods, other high temperatures, and special coating requirements for industrial use. See, widely used application involving flues and stacks, hoods. Okay, other high temperature and special coating requirements. At the same time, copper. It is mainly used for certain chemical exhaust. Chemical exhaust condition you can prefer, and ornamental ductwork purpose also you can prefer this one. These are our duct materials. Okay, now clear na? Where are we are when we are applying this duct materials
Mm.
means duct sheets. Next, you can go for aspect ratio. Do you have any idea about this aspect ratio?
Mm.
Cost balancing purpose, we are using this aspect ratio rule only applicable for rectangular and
Duct
square
side?
ducts. Tell me.
Duct side.
Not understand. Pardon?
It's okay, sir.
Okay. Aspect ratio only we applicable for rectangular and square ducts. Okay. First, what is this aspect ratio? Most of the persons as no aspect ratio, they are considering width by height formula, but that is not a correct. Aspect ratio means we need to consider long side to the short side. Okay, long side to the short side means in side condition always we need width high compared to the height or otherwise equal to the height, right? If we
Mm.
have
Yes.
more than width is less compared to the height, okay, that condition is not applicable na side. Okay, that is your aspect ratio means. Okay, if you are doing like that, automatically affected to the your pressure loss, your friction loss. Okay, increasing your friction loss more. If you increasing your friction loss, automatically your pressure loss also increasing na? When our pressure loss is increasing, okay, that is automatically affected to the our cost. Okay, that's why what we are doing here means, just you can see here one more point is there. This is the ratio of long side to the short side of the duct. As the aspect ratio AR value increases, more metal surface is required for the duct for same cross sectional area. Now I can see this is the ratio of long side to the short side of the duct. I will read one more. As the aspect ratio increases, more metal surface is required for the duct of same cross section area. Now I can see here we have case 1, case 2, both cases is there na? Case 1 condition we have, case 2 condition we have. In these two conditions we have one condition rectangular duct, one condition square duct, both is there na? In these two conditions, just you can observe here, see, here to here, here to here, at the same time here to here, here to here. In this condition you can see here we have width this one, height this one. In this condition width by height 8 feet by 2 feet, you are getting 16 square feet. Next 4 by 4, 16 square feet. Okay, both area is same, cross sectional area is same, but perimeter value is different. Just you can see 8 to 10, 8 to 10, totally 20. Now here we have perimeter means our duct area. Okay, duct metal surface area we have 20 feet, but here 4 4 4 4 perimeter, total is 16 na? 16 square feet. Okay, in these two condition 20 and 16, which is higher value, this one. In this duct also our air is flowing, cooling air. In this duct also our air is flowing. In this condition here also our air contacting to the duct metal surface, and here also our air contacting to the duct metal surface. Here our air contacting to the more metal surface, here less metal surface. Okay, when our air contact to the metal surface or duct surface, that condition automatically it will generate some friction. Okay, it generates some friction. Okay, it is generating some friction, automatically increasing your pressure loss also. Friction is increasing, automatically pressure loss also increasing. That's why here you are getting more pressure loss in rectangular ducts compared to the square duct. Okay, that's why as per your site condition always you can design your ducts near to the square or square ducts. Okay, then we can maintain our cost very balanced. Okay, always you can maintain your AR value 1 or less than 4 only. Okay, then you are getting better cost for the client. In case if you are using more, that is affected, more affected to the monthly bill running cost condition. Okay, that's why we need to balance. Okay, in case you don't have any chance in site condition, we have don't have any chance, just we have 1 feet 2 feet, okay, your site clearance area, that kind of situation you can prefer normally, we don't have any possibility for that case. Okay, that kind of situation applicable. If you have any possibility, you can prefer between this ratio. Okay, is it clear guys?
Yes.
Yeah.
Next here we have notary. As per SMARTNA, AR should be less than 4. This is SMARCNA standard. As per SMARCNA, we need to maintain this less than below this one. And as per AR decreases, already I told this point, as per AR decreases means aspect ratio decreases, less sheet metal surface contact with air results, okay, will decrease the friction and the running cost of the project also. Okay. Next, at the time of designing, try to make the duct shape close to square. Already told this one also. Perfect aspect ratio is called 1 for square ducts. Okay. Now you can see here we have friction for different shapes. Just you can see here we have three shapes, but area is same. Cross section area is same. Here also 1 square feet. Here also 1 square feet, and here also 1 square feet. Circular condition, we have perimeter means here nothing but circumference 42.5 is there. Here you no need to consider aspect ratio, only applicable for square and rectangle na? Okay, here we have least
Mm.
surface area, just you can see 42.5 is there, contacting area, air contacting area. But square condition, 1 feet means 12 inch by 12 inch na? You are getting 48 perimeter. In this 48 perimeter we have one aspect ratio 4 by 4 na, sorry 12 by 12 na, 1 you are
Mm.
getting. That condition 30% more compared to the circular friction loss. At the same time, rectangular condition you can see 24 by 12. That condition we have perimeter value 60 for 41% more compared to the circular. Okay, like this, automatically increasing your pressure loss and friction loss. Okay, that's why we are using or we are creating rectangular condition near to the square duct. Circular condition you can take circular, we don't have any more pressure loss, we have constant in that case. It depends upon the your perimeter means circumference. Next, here we have note. As per shape change, the perimeter change, the duct friction loss increases with increasing in our perimeter for the same area. Okay, this is our duct materials, aspect ratio, and velocity classifications. At the same time, pressure classification. Now clear this one. Is there any doubt in this?
Mm. Yeah.